Hello, my dear students. In the last part, we have solved numerical problems based on lens formula and magnification of lens. And in this part, we have to learn power of lens and combination of two thin lenses. So let's see how to define power of lens. So first, we will define power of lens. Upon the power of lens, can I define the word again? Define the way it is defined as the ability of lens to converge or diverge a beam of light incident on it. Haidi lens to ki magi powers kay dubu sagi lens to da koina beam of light ko haidi light rays abunama lens to da jaira kanda lens to na kayam yamna focus the converge to bunga mi na chagana diverge to ba haidi focus tagi sathokiba haitare focus the converge to na chaga diverge to ko it depends upon the nature of the lens aduna sagi power of lens har the lens na light se kyam yam converge to bangami na chaga na diverge to bangamge have tai say in this figure. Say in case of convex lens, let us consider two light rays incident on this convex lens and let the two light rays are parallel to the principal axis silai je ko atadi refraction thom tung da sagi refracted light rays focus the converge the wave ko adu sigi figure number 2 na concave lens ni aduna concave lens na sigi two parallel light rays incident on the concave lens se refraction thom tung da diverge the winner lakto but that is they appears to come out from the focus sagi tholakpa maneba aduna sigi convex lens na sagi refracted light rays converge am to bang ngai power sawi haiduni concave lens na light rays diverge am to bang ngai power sawi na haiduni adita de sigi figure is the sagi power is related to focal length related oi that is focal length say am sangai focal length am sangai less converging or less diverging higher kanelo aduna focal length pi ngai yam converge tawi natragana yam diverge tawi na haini aduna power of lens se kari manage bu akoina smile have yai it is equal to the reciprocal of focal length of the lens that is power of lens capital P equal to 1 by f that is reciprocal of focal length ko adu mag SI unit se koina diopter do only its SI unit is diopter denoted by capital D. So we may write like this: 1 diopter. That power is 1 diopter. Ko we har gadi sidrega focal length se meter on gada SI unit ko aduna 1 by 1 meter lani or 1 meter inverse hai ganeba. Or 1 diopter is 1 meter inverse. So how can you define 1 diopter? 1 diopter is can I define the way it is a power of lens of a focal length having 1 meter. Mana har siare aduna 1 diopter is a definition je easy. So power of lens is said to be 1 diopter when the focal length of the lens is 1 meter, or it may also be defined like this: 1 diopter is the power of lens having focal length 1 meter. So we can say that smaller is the focal length of the lens, larger will be the power of the lens, and vice versa. Focal length being power of the lens awani aduga the reverse is also true havani, that is focal length already power do pikaniya. And next we have to discuss about the combination of two thin lenses. That is, in this topic we have to try to derive the equivalent or effective focal length of the combination of two lenses and the effective power of combination of two lenses. So let us see how to find out effective focal length and effective power of combination of two lenses. In order to derive the expression for effective focal length and effective power of combination of two thin lenses, first we have to see this ray diagram. So in this ray diagram, let us consider two thin convex lenses denoted by L1 and L2, and they are kept in contact with common principal axis. Other similarly is a convex lens ani laure yamna paba convex lens oigadaba haibadi akoi sida lauriba optical center ani je O1 O2 je yam nangna kadobuni aduga lens akoina L1 L2 cover se aduga lens ani je thambada contact oigadaba samna kadaba aduga makoi principal se common principal axis se common oigadaba ko chile is principal axis later. And here O represents a point object which is placed in front of lens L1 at a distance U from optical center O1. And OA represents a ray of light emerging from this point object and incident on L1. Then after refraction, the light ray move along AB. And here, if there is no second lens L2, then this refracted light ray AB will meet the principal axis at I-dash, and this I-dash will be the image, that is the position of the image formed by lens L1. Karigumba sigi lens L2 je leiramdraba atu itardi leiramdragadi sagi lens L1 na form tawudariba image se I-dash oiduneba ko sumna sigi AB je refraction to kan si sumna lakani sigi figure demo AB I-dash se straight line oidobuni ko AB na solid line ati full line oide aduga B I-dash na dotted line oyobo ko haiti AB je sumna lakanda principal axis ka I-dash intersect only harini. And here B-dash represents distance of I-dash from optical center O1. So if we consider lens L1, object distance is U and image distance is V-dash. And let us consider second lens L2. And in case of lens L2, the image formed by the first lens, that is I-dash, will act as object for second lens L2. So this refracted light ray AB appears to come out from this I-dash. Then after refraction through L2, the refracted light ray AB again suffer refraction. Then the refracted light ray will finally meet with the principal axis at I at a distance V. So I represents the final image formed by the second lens L2 for the object I-dash. And sida urize sida I-dash lens L1 na form toba image na lens L2 gi object oina logani aduna sida leriba refracted light ray AB je I-dash tagi lapa mangani aduna sigi refracted light ray AB je sumna sapen muta sigi lens L2 da mu refraction thokani aba aduna refraction to matung da saiki principal axis ka capital I da kaunarani intersect tawrani aduna sigi capital I je saiki lens L2 na form toba image kanagi object virtual object I-dash ke. And here B represents distance of I from the optical center O2. And if we consider the second lens L2, object distance kaya no hafhargadi B-dash logodaba akoina the same way the B-dash se O1 ga I-dash ka distance ni adubu since the two lenses are thin, so O1 I-dash should be approximately equal to O2 I-dash. Aduna O1 I-dash ka O2 I-dash ka approximately manin lo boyai. Aduna object distance ko na B-dash oirani lens L2 ki aduga image distance na I oirani. Then using lens formula, that is 1 by f equal to 1 by v minus 1 by u, we can derive effective focal length and effective power of combination of two thin lenses. So let us see. So now we may write like this. Let us consider two thin convex lenses L1 and L2 having focal lengths f1 and f2 respectively. The two lenses are kept in contact coaxially. That is common principal axis I am recall. Sigi figure is the full isini sida is a point object O is placed on the principal axis at a distance U from O1, that is optical center of lens L1. A ray of light OA emerging from the object falls on lens L1. Celerible light rays ko. Object ki thoro light rays lens L1 ye happening. After refraction, the refracted light ray AB will meet the principal axis at I-dash having distance B-dash from O1 if there is no second lens L2. Or refracted light rays principal axis ka I dias intersect taurani distance na b dias from O1 karigumba sigi lens L2 je lairam dragadi. Then we may write like this. Hence I dias represents the position of partial image formed by lens L1 for point object O. Our similar I dias se koina real image ay tasing na ubding amoy koina partial image na logoni. Using lens formula in lens L1, we may write like this: 1 by f, that is reciprocal of focal length, equal to 1 by v dias, that is reciprocal of image distance, minus 1 by u, reciprocal of object distance, and write it equation number 1. Next, we may write like this: in fact, there is second lens L2. Ako yung second lens layram dragadi habido tasing bagidi second lens L layabo ko. I dias will act as partial object of lens L2. Sila I dias na lens L2 gi bagi object when you ini. So the refracted light ray AB again suffers refraction through lens L2 and meets the principal axis at I at a distance V from O2. That is optical center of lens L2 as shown in figures. Aduna sila iba refracted light ray just zoom na sa pemuta lens L2 je mu force ato ini aduna amuka maze refraction to ni aduna refraction to matung da refracted light ray je I dias ta principal axis ka intersect roneba adu magi I gi distance ti V from O2 haibani. Hence capital I represents image formed by lens L2 for a partial object I dias. Using lens formula in L2 we have aduna lens formula je mu lens L2 de mu apply to zeba aduna magi focal length f2 ni object distance t L2 gi di v dias na logineba maram de I dias na lens L2 gi di partial object oiduni aduga sigi v dias se koina O I dias se approximately O2 I dias ka mane lobo ya ko maram de sigi lens ani je amna pavni na aduna 1 by f2 equal to 1 by v, that is image distance, minus 1 by object distance, that is v dias ko, and write it equation number 2. And next equation la to is ngasa ko na fangiba equations 1 to 2 plus torus ko na effective focal length to ko. So we may write like this: adding equations 1 and 2 we have 1 by f1 plus 1 by f2. Kasi ako na fangim equation 1 and 2 do left side tali ba term to plus tawro, right side tali ba term to plus tawro zeba. Ito 1 by f1 di 1 by v dias minus 1 by u, equation number 1 di ito. Ito ko 1 by f2 aga na 1 by v minus 1 by v dias to. Ang equation number 1 go to plus tawro kanda ko is minus iba yani ko. Then si bracket open tawro kanda 1 by v dias minus 1 by v dias cancel salani, then 1 by v minus 1 by u smailani. So write equation number 3. See later. Then matang dalam tu sina sida lagi ba lens ani je. Koi na lens ani contact samjana raga thami ba lens ani je. Koi na lens ama oina lau seba. Aduga magi object na o oiba aduga image na I the form to ba aduga akoi na lori ba lens to magi focal length na capital F oina lau seba. Aduga smile bi let the two lenses be replaced by a single lens of focal length capital F, which forms image capital I at distance V of an object at distance U from the lens. For this lens, that is lens from the apply to say ba kuno sita single lens amana mo syndrome ko sig lens ani ja adugi single lens to gi lens from la mu igi height 1 by focal length, that is capital F, equal to 1 by image distance, that is V, minus 1 by object distance, that is U, and write equation number 4. On equation number 3 to 4, so we compare to the right side of terms is some money, on the left side of terms 1 by F equal to 1 by F1 plus 1 by F2 and even. So next term, so next we may write like this: comparing equations 3 and 4. Question 3 4 compared to we have 1 by f, that is 1 by capital F equal to 1 by f1 plus 1 by f2. Other equation number 5, so they are by capital F now represent the result equivalent or effective focal length of combination of two lenses. On the lens and you can punjalakanda magi total focal length to higher sige format apply to reneva si capital F se ko aduga sidagi akoina we can find out total or effective power pudusu yare aduna power of lens di reciprocal of focal length ni aduna reciprocal of effective focal length laire or we may write 1 by f1 plus 1 by f2 minus the ibayai. Then if P1 and P2 represent power of lenses L1 and L2, then this 1 by F1 is equal to P1, 1 by F2 is equal to P2. So total power of combination of two lenses placed in contact should be equal to algebraic sum of the individual powers of the two lenses. Aduna capital P P1 plus P2 harus ya CJ 1 by F1 di P1 laire, 1 by F2 di P2 laire ko ita sulaire. Aduna equation number 5 sina effective focal length to payarni, equation number 6 sina effective power to payarni. Kari makoy na sida loriba lens ya amana concave oraba amana convex oraba. Suppose L to Z concave oram tardi ako na calculation to matamda focal length F to Z negative sign half ko nebo sina convex na to oibagi plus na to oireni ko kari gumba lens L to Z concave lens oramadi si minus F2 oitare aduna calculation ki matang dedi we have to always consider sign convention ko wiadi